Welcome back friends. In today's lecture we are going to deal with one of the very important concept of mechanical engineering as well as civil engineering. Basically, in case of mechanical engineering we have studied this concept in strength of material as well as in design of machine elements. So let us start with this concept: stress strain curve or graph. Stress strain curve. Basically, before starting with this entire concept, I want to tell you few basic things which are required for plotting of any graph of any subject. So what is it? Let us suppose I want to plot a graph. These things we have studied already in 3rd or 4th standard, but we forget as time pass on. How we plot a graph? To plot a graph, we take independent parameters on x-axis, y, dependent parameter on y-axis. We take independent parameter on x-axis, while dependent parameter on y-axis. Means all the quantities which we are going to plot on y-axis, the values of all these components based on these parameters. So this is how we plot a graph. Now, how we calculate output of a graph? Let us suppose here it is a curve like this, and it is said that calculate the output of this graph. How we calculate the output? We take the point on graph, trace it on the base axis, and then calculate the area. This area is nothing but output of that graph. So now let us move with this stress strain curve. Basically, this stress strain curve belongs to ductile materials. Ductile materials. Ductility is a property by virtue of which you can deform a material into wires, which is called as ductility. So this stress strain curve is useful for ductile materials, or it is the stress strain curve of ductile materials. The material is mild steel. So it is stress strain curve of mild steel, which is a ductile material. Now, I am having one question. Can we exchange the portion of stress and strain? Means, can we plot stress on x-axis and strain on y-axis? The answer is no. We can't do that. Why we can't do that? Because this stress strain curve is generated with a machine called as universal testing machine, generally referred as UTM. Generally referred as UTM. Okay, so what is this UTM? Let us suppose this is a chalk. Now let us consider this one. Let us consider it is a mild steel specimen. So how the arrangement is done in that UTM? There is one lower jaw which holds from bottom side, one upper jaw which holds from upper side, and then as soon as you start the machine, from both the sides pull force will be applied and this mild steel specimen starts stretching. The upper jaw will try to move it upward side, while the lower jaw will try to move it downward side. Okay. So what will happen? When the stretching action continues, the first change happens will be the length of specimen will increase. Means what we have occurred first? There is a dimension change. Dimension change means what? What is strain? Strain is change in dimension with respect to original dimension. Means first thing occurred is there is a straining action takes place. Means strain comes first. Therefore, strain is independent parameter, and hence we have plotted strain on x-axis. Therefore, we have plotted strain on x-axis because it is independent parameter. It comes first in the picture. Therefore, we have plotted it on x-axis, and depending upon amount of straining, equivalent amount of stress will be developed. Means if straining is more, stress development will be more. If straining is less, stress development will be less. That's it. Means strain is independent parameter. Therefore, we have plotted it on x-axis, while stress is dependent parameter. Therefore, it is plotted on y-axis, and we can't interchange the positions. I have seen many times students draw all the curves in accurate manner, but here they write stress, here they write strain. 0 marks. Okay. So now let us deal the curve one by one. Let us see here. I have given 5 to 6 points. This is point A. This is point B. This is point C. This is point D, point E, and point F. Now this curve is plotted and it is again defragmented in 4 to 5 parts. Let us say this AB region is called as proportionality region. What is proportionality region? Within this region AB, the value of stress is directly proportional to value of strain. Means equal amount of straining, then equal amount of stress will be developed. That is, Hooke's law is valid. There is one law, Hooke's law, which states that stress directly proportional to strain within elastic limit. Hence, what is proportionality region? It is denoted by AB. In case of this proportionality region, stress directly proportional to strain, and therefore Hooke's law is valid within this region. Now, next is AC region. This complete region AC. This AC region is called as elastic region. There is a property called as elasticity. So what is elasticity? It is a property of material by virtue of which it can regain its dimensions if the applied forces are removed. If you apply the forces, dimension will change. If you remove the forces, dimension will be regained. This property is called as elasticity. So within this elastic region, elastic properties holds good. Means if you are stretching this rod within elastic region, it will stretch, but if you remove the applied forces, it will come back to its original position. Hence, the region AC is called as elastic region. So what we have seen, up to this point C, elastic properties are valid. Means if you are removing the applied forces, the component will regain its original dimensions, and this entire region is nothing but elastic region. This entire region is nothing but elastic region, while the region beyond point C is all plastic region. What is plasticity property? If you have applied forces on a component, if its dimension changes, the change in dimension is permanent. If you remove the forces, it will not regain its original dimensions at all. This property is called as plasticity. So, if suppose after point C also, if you are again applying forces, if you are again stretching that mild steel rod, what will happen? Plastic deformation will start at point D and the plastic deformation completes at point E. This is the first set of plastic deformation. It is given UYP and LYP. What is UYP? Upper yield point, that is start of plastic deformation. E point, lower yield point, that is finish of first plastic deformation. Means what? Beyond the point D, if you are again applying the forces, then the stress, look at here. In initial stage, stress is going on increasing, stress is increasing, but after point D, stress is reducing. Why? Because plastically deformation starts and now the material could not regain its original dimensions. Always remember, this lower yield point is always fixed for a material. The lower yield point is always fixed, and design of ductile material is based on this lower yield point. Okay. Now we are seeing that the curve again start increasing to upward side. Why this has happened? The first plastic deformation is completed now. Now what will happen? Let us suppose this is a rod. It is stretched, for instance, plastically. Then For another set of plastic deformation, the fibers will reorientate and they again resist, therefore stress increases. Look, here the stress decreases, again they start resisting for another change, the stress is increasing. But now look over here, the stress is increasing in very low quantity, but strain is increasing very high amount of strain for very low amount of stress. Therefore, the region EF is called as strain hardening zone. What is strain hardening zone? For sustaining any small amount of load also, there is very large deformation. Large deformation is a sign of failure. Means that material might get failure after this. Okay, large deformation is a sign of failure. What is happening? For very large, very small amount of load also, there is large deformation happening. Large straining is happening, as you can see. Large straining is happening. Hence, this region EF is called as strain hardening zone. Now here it is written that USP. This USP is called as ultimate strength point. This is ultimate strength point. What is ultimate strength of a component? If suppose you are applying a load beyond a particular limit of a component, then the component will break or will unable to function properly beyond that strength of a component beyond which the component may fail for any amount of load. That strength is called as ultimate strength. Hence it is ultimate strength point. Means if you are continue loading beyond this point, the component may fail at a point F, which is fracture point. Now this entire curve I have split it into two parts. First region is elastic region, next region is plastic region. Okay, now what are the things you should remind as per your competitive exam point of view from this entire curve? Look, this curve is of ductile material, which is mild steel. From where you get this curve? From universal testing machine. Where to plot strain? We always plot strain on x-axis because it is independent parameter, and stress we plot on y-axis because it is dependent parameter. Now, okay, we have studied this entire curve now. We have seen that in initial there is proportional region, the elastic region, then yielding happens. Yielding means start of plastic deformation. Yielding happens, then strain hardening, and then fracture. But what is the output of this curve? Output of this curve is to calculate toughness of a component or toughness of a material. Now how we calculate area? The output of a graph. Take initial point, take final point, trace it on the base axis, then calculate the area. This is your output of this graph. This is your output of that graph. Now from this stress strain curve of ductile material, we can calculate toughness of that component. What is toughness now? Toughness is ability of a material to regain some amount of energy before failure. Means whatever this entire area, during this entire period of loading, that mild steel specimen absorbed some amount of energy. You are applying force, he is taking force, that material is taking force. Means where is that force going? It is consuming that force as energy, and if excess amount of energy you are supplying, it will fail at a point. And this entire region represents toughness of that component. Thank you very much. Stay tuned. In next lecture we will deal with some another concept. Thank you very much.